All right, so our problem is we're supposed to graph x squared plus y squared minus 169 equals 0, then find the derivative of y by implicit differentiation, and then find the slope of the graph when x is equal to 5. All right, so many different things we have to do here. Now, first off, if we rewrite this as, now if we get pencil here, x squared plus y squared equals 169. Hopefully you recognize that that's an equation of a circle. And we know that then we can find the radius of the circle by taking the square root of 169, and that means the radius is going to be 13. And so if they want us to really graph this, we know that we're going to have a circle, as good as I can draw a circle anyway. It looks like that, and our radius is 13, so all these should be 13, but of course they're not. And so that would be what it is. And so then when we want to find the slope of the graph when x is equal to 5, well, if say that's 5, there's going to be a slope here, and there's going to be a slope here. So we're going to have two different slopes where it's going to be a tangent to the graph at that point in time of x equals 5. And so we need to have two numbers there. Well, what would they be? Well, if we plugged in 5 for x, so that would be 25, and we take the 169 over, then we're going to get 144. And so we're going to have the 2 points. One of them is going to be 5 plus 12, and the other one's going to be a 5 minus 12. So those are 2 points we're going to actually have here for solving for the slope once we get to that point in time. But before then, what we're going to do is we're going to rewrite this kind of like they did in the last problem. They had x squared, and then they put, instead of y squared, they put the y of x. And so we have y of x squared, and then we have minus 169, and then that's equal to 0. Okay. And now I'm going to go ahead and put the d dx, and I'm going to put it on all of the things, kind of like they did, except they forgot to put it on the 0, but I'm going to put it there. So that gives us d dx of x squared, and then plus, and then we have a d dx of y of x squared minus d dx of 169, and then equals d dx of 0. Okay. All right. Well, the derivative of x squared with respect to x, that's going to be what? 2x. Pretty easy. Now, what's the derivative of this with respect to x? All right. So here, what we have to think about is we're going to do kind of the chain rule and everything. So we're going to have first, that's going to give us plus 2 times, and then it's going to be y of x. And we probably better go ahead and keep the brackets on, and it's going to be 2 minus 1. And then we have to take the derivative of what's inside. Well, the derivative of what's inside, we're going to call that y prime of x. Okay. Now the derivative of 169 and 0 are both 0, so I'm not going to put plus 0. I'm just going to say equals 0 here. Okay. We could have a minus 0 here, and then that disappears, but let's leave it just as that because we know that that goes to 0 and that goes to 0. All right, now let's go back and kind of put it back in the format where we have just y's instead of the y of x. So if we do that, that gives us 2x plus, now this is y of x to the 1 power, so that's going to be a 2y. Now this is going to be a y prime of x equals 0. Okay. Now we want to find the derivative, so we want to solve this for y prime. So we're going to take 2x to the other side, so we'll have 2y, y prime, and I didn't really want that y of x there, but let's erase it. I was just in a habit there of doing it. All right, so 2y, y prime is equal to, now I took that over, so that's a minus 2x. Solve for y prime, that's divided by 2y. And so y prime is equal to, well, our 2's cancel, so we get a minus x over y. So that's my derivative through implicit differentiation. Now they want us to find the slope of the graph, and again, at those 2 points. So how we're going to represent that is we're going to say y prime evaluated at each of the points. So we have it at 5, 12, and we'll also find y prime evaluated at 5 minus 12. All right, so that's going to be what? Well, we plug everything in here. We have a minus x 5 over 12 Well, that's one answer. That's my slope there. So that's the slope. And the other one is going to be what? Well, here we're going to plug in a minus 5 over a minus 12. So that's going to be actually just a positive 5 over 12. And that's going to be my second slope. So those are the two slopes I get, again, depending on if I have this one or I have this one. And if you notice that this one, 512, it looks like it's going to be a negative slope. It is a negative slope. This one looks like it's going to be a positive slope, and we do have a positive slope. So what we see should be what represents our slopes when we get done there. All right, so let's stop there, and we'll come back for more.